yeah, we did the inscribe. And last thing we talked about was the tessellations, right? Like, can you use the shapes to tile a floor? And it's always the emphasis is on where those, if you pick a point and you look at the interior angle of this one shape, the interior angle of the other shape, and you must cover 360 degrees in total, right? So here, this might be a question where you wonder what other shape could come in here and meet the criteria, right? So you can actually tile that floor. Okay, so I'm gonna start with 25 here on page 33, question 25. And I know the answer key's out there, but maybe, just maybe, I might mention something that comes up. I'm also going to say that there's going to be always expect some quadratics on the tests leading up to our cumulative. So mainly, primarily the 4 types, right? So type 0, 1, 2, 3, one of those regression types question, make sure you brush up on that. Make sure your study sheet has stuff that pertains to that. Okay, because it's very important. It follows you around. Anybody say anything? No? Okay. All right, the diagram below shows a regular hexagon with a regular pentagon, right? N6. Some of you were getting that wrong as well, the number of sides, so make sure you count carefully. Just look at the picture if there's a picture, count, right? Attached to one of its sides. Work out the size of the angle marked with X. Right, so they want this one here. So I guess I should erase this for now, and we focus here. So the game plan is we're going to find this interior angle of the pentagon, sorry, hexagon, and we're going to find the interior angle of the different colors here. Right, so we're going to focus on this one, and then we're going to focus on this one. And we know that a full circle, right, is 360 degrees, right? So it's fairly simple. Maybe you can even write inside if you want to, but the interior angle of a 6-sided shape is just 6 minus 2 times 180 divided by 6. I know this one is going to be 120 degrees. Okay, make sure you show your steps along the way. With these basic shapes, I'm okay with you just saying it's 120, but I prefer you working out. It takes a couple seconds, right? So the interior angle of a 5-sided of a pentagon is 5 minus 2. It's just so you don't forget the formula even, right? Some of you, that's a decimal, that's 120 something. I always need to double check. Oh no. 3 times 180 divided 108. Never mind. No, 108. So you got 108 and 120. Okay, so this is 120 here, the interior angle, and this is 108. Okay. Red and blue. And if you're done this, you're just watching this, right? And you maybe get ready to add stuff, right? So to get X, I would just go 360 minus 120 minus 108. Okay. And that is 132. 132. Is there a shape that you can think of that would allow you to tessellate this? We would essentially look for an angle for an interior, a shape here that has an interior angle of 132 degrees, correct? Um, so I will add this. Can you find a shape that will tessellate this is where I'm adding, right? I'm just adding as I go because it's complicated to always redraw everything. So I'm like, why not use this to get you started, right? So what this is my approach. This is an interior angle, right? The interior angle is 132 that we're looking for. Therefore, the exterior angle of the shape I'm after would be 180 minus 132. And that exterior angle would be 48. So I will make a note, the shape, and this is small, I know. The shape I'm looking for has an exterior angle of 48 degrees. That's what you just did here. And if that makes sense to you, you don't need to write it down. That's fine. I'm just going to turn off the lights here. Sorry, that's really small, I know. Anyways, so the shape I'm looking for has an exterior angle of 48 degrees, right? If that's even gonna work. So I'm gonna use, I'm just gonna put an arrow here. Therefore, 48 degrees, the exterior angle, I know it's 360 degrees divided by n. That's the formula of the exterior angle. I put a 1 here just to show me that I have to cross multiply and divide, right? So to get n, I have to go 360 times 1 divided by 48. And this is not going to work, right? We can 7.5 sides, right? And then we'll say since it isn't, I know your English teachers are gonna not gonna like that, right? Since it isn't a whole number, no shape works. There's no shape that will make this work. There's no shape that can tessellate this. If this had been 8, then we would know that an octagon would have done the trick, would have completely filled this gap here. But it just didn't. So if you would have rather wanted to use the interior angle formula, which a lot of you like you stick to that and that's fine, right? You would have still arrived to the same conclusion, 7.5. N is 7.5, okay? And it doesn't work. It has to be a whole number for it to work. And this is just me adding, but maybe the question, if it would have been worded like this, find the shape that would allow you to tessellate this. If the question says find the shape that will allow you to tessellate, that means that it will work. You just have to figure out which one is it, right? So in this case, there is nothing that works. So we're done here. Okay. This is, maybe I will just box this in and just say that this is an aside, right? This is an extension to this problem, right? Extension. There you go. Extension to the problem. That way you're not wondering why, how did that make it in there, right? 26. This shape, right, with these vertices is a regular octagon for us, regular is very important because it tells us that all interior angles will measure the same, all exterior angles will measure the same, and all the central angles will be the same as well, right? Because it's just all sides measure the same. Work out the size of angle PTS. So PTS is right here. So PTS is right here. Okay. Why don't we call it X, right? Thank you very much, right? You can absolutely do that on a question that uses the three-letter notation for angle. And then there's Q, P, R. Q, P, R. What's happening there? So you need to make that angle happen. So QPR is this angle right in between there. Okay, we can call that Y. So this is X and this is Y. So you've got color coding, everything happening here, right? To make your lives easier. If you have a highlighter, bring it to the test even, right? If you have colors, bring it, it helps. Okay, so we'll figure that out in a bit, but before you do anything, find the interior angle of this shape on the outside. We are told it's an octagon. Let's say I don't tell you this. This is the trick. You make a check mark, you start counting from here. 1, 2, 3, 4, 5, 6, 7, 8. And then you don't double count that one, right? So that's 8. So n is equal to 8. Let's figure out the interior angle of an octagon. 8 minus 2 times 180 divided by 8. And that is it 135? I'm pretty sure. It's been a while. It's been a week. Yikes. Yeah, it's 135. I just double checked. So that's what you start off with. Start with this. Start here, right? You always want that interior angle because now you know that every single one on the inside is 135, right? Like just to reiterate and make sure you understand that, right? That's what you just found. I'm not going to put this down on the intersection here because it's going to be too busy, right? But the ones that are doable, I write down 135 there. Maybe from the outside, we can go and say that's 135, like that whole angle, right? Just to prove that point. And I'm going to focus on X first. And if you think of it, if you count this side here, it's 1, 2, 3, 4, 5. It's a pentagon here, right? So we'll work out X over here, and I'll draw my pentagon like this, right? So you go angle, angle, and then one more. If you need to do that, some of you don't need this, right? That's fine. Right? X would be right here. I just transferred it here. I know that this is 135, 135, 135. And your formula sheet, or sorry, study sheet, you should probably have that the sum of a pentagon is 540, right? That will make your lives a lot easier. So X is going to be 540. That's the sum of a pentagon minus 3 times 135, right? Over 2. And don't forget to put the top in brackets. I always figure out what the top is and then I divide it by 2. I believe this one was actually on the quiz, right? No. So this is 135 exactly divided by 2. That's 67.5 degrees. So you just found that this is 67.5 and this is 67.5. Like That's why you're splitting it in half, because, right, both of these are 67.5. But x is nonetheless is 67.5. So you found that, that's done. Okay. Now we're going to figure out y over here. Keep in mind this is a regular octagon, so this side is the same as this side. So you should see that this is an isosceles triangle out here. I don't know if you see that, but to solve y, I'm going to draw out that triangle. This is 135. That 135 follows me. And I'll put the y on this side just like here, right? It follows me there. This is an isosceles. So y is going to be 180, because that's the sum of a triangle, minus 135. There's only one. We're going to divide that in half by 2, right? And that's 45 divided by 2, which is 22.5. Does that make sense? On a Monday after the break? It's tough, right? Let's add, right? Let's see if you could handle more. So what if this question said UTP? So C is find angle UTP. I know that, right? This is brand new, so if you're following, if you're following, this is where you add stuff, right? And this one is actually not too bad at all. Okay, because we know that this vertex at T here, that whole thing is 135. We know that this is 135 here at this intersection between the outside, right? The sides of the octagon. So to find what should we call a Z? We'll call it Z. I have a different highlighter. Right? Let's see if this smudges everything. No, that's pretty good. So UTP is right here, and that is Z. And we're going to call this angle Z. Do that. If this throws you off, just make it a one letter, right? Use a highlighter if you need to. You don't have to. But Z, angle Z, I'm just going to take the 135 and I'm going to subtract angle X from it. So Z is 135 minus 67.5. And it will happen to be exactly the same. But careful, don't make the assumption that it's always going to be like it. Okay? It just happened to be the case because it's an octagon. You're out of space probably, right? I was going to try another one. I was going to draw a diagonal here. And then we would have a trapezoid here, a four-sided. But there'll be more down the road. We'll just move on. Yeah. So we found all the angles that we're asked to solve. So we're going to move on. Work out the size of angle X. Yeah, that one is a good one. Let's go to 27 here. Okay, so we've got a regular pentagon that's important to me, n is equal to 5, right? QR and TS are extended, right? These two sides essentially are extended to meet here. At U, work out the size of X. Again, what are we going to start with? There are no numbers. So you start with the interior angle of the pentagon. Okay. Do not start with the interior angle of this because we don't know if this is an equilateral, right? We don't know that. But we do know that this is regular. So interior angle of a pentagon, you already know this, right? Is 108 degrees. That means that this is 108 and this is 108 here. Everything is 108 in fact, right? And so that means, right, this essentially, if you think about it, these are straight lines here, so they're supplementary. So we know that this will be 72 and this will also be 72 here. These are essentially the exterior angle of pentagon. Okay, the 72 is the exterior angle of pentagon. So now we can find x. So angle x is just going to be 180 minus 2 times 72. That's 144, so we are at 36, right? Done. I'm thinking, yeah, I'm just gonna leave it. I'm just gonna leave this one. Let's go to 28. STUV, right? So STUV is the square with 3 of its vertices ST and U on the sides of the equilateral triangle. Oh, that's key here, right? Equilateral triangle, so we know that these sides are all the same length. Work out the size of angles marked X and Y. X and Y. This one is actually not too bad, okay? Because we know that this is a square. We know that there's a 90 here, right? And we know that this is along a straight line here. I know a lot of your right, straight line here. So we've got 50, 90, and X. I guess we'll just focus on explaining. Straight angle is equal to 180. That's how you justify it. And then we'll move over to Y. I also have a straight line here. I'm going to use that. That's going to be my approach here. This straight line. What do I know? I know that this is a 90 here. What else do I know about this triangle? Can I assume something is true here? Well, we know that this big one here is an equilateral, correct? And all angles in an equilateral triangle are always 60, right? So we know that this is 60. I will just do this. Interior angle of a three-sided regular polygon is going to be 3 minus 1 times 180 over 3. 3 minus 2, sorry, why did I do 1? Yeah, 3 minus 2. So that's 60 degrees. So all of these in each corner of that big triangle, that's almost like my big polygon. right? That's 60. I should have started with that actually, but anyways. So if I now know that this is 40, right, I figured out that x is 40, so this must be 80 here, right? Because 60 and 40 is, so I will give this a temporary letter here, Z. Some of you do that as well when you do the work. Z is going to be 180 minus 50, no, minus 40, sorry, minus 60, right? So Z is going to be 80 degrees there. And so Y is simply going to be 180 because of this, the straight line minus Z minus 90, which is that one in the middle there. So it's just going to be 180 minus 80. That's 100, right? Minus 90. So Y is equal to 10 degrees. So it's obviously not drawn to scale, but there it is. Does that make sense? So you just have to be creative, okay? Like don't think of it as static, right? Like add stuff to it, show how you got that, but don't let me just guess, right? Like just put in y is equal to 10. Like I have no reasoning there explaining how you got that, right? So if I asked you to explain, then I would expect here next to it just saying straight angle is equal to 180. Here you would use the sum of triangles equal to 180, right? And so forth. Explaining, you know what? I must say you're pretty good at that. That is the end of that booklet when it comes to inscribed shapes. I wanted to I think I'm going to go back a little bit, just backtrack before we go to that other chapter test. Let's go to page 28. Yeah, page 28. So something like this, it doesn't matter what shape it is, how many x's there are, it still works the same way. Okay, you just need to know what is true about those angles, right? In a triangle, they should add up to 180. If they're consecutive interior, right, those two add up to 180, right? If they're alternate exterior, those two expressions are equal to each other, right? So you got to think, how do I put this together to make it work? Okay. Let's try this here. Work out the value of x. So they're only asking for x, no angles whatsoever. So here, for A, right, sum of a four-sided S of 4, right, is 4 minus 2 times 180. That's it, right? And we know that that's 360 degrees. No surprises there, right? So I know that x plus, right, I'm going to start up here. This angle plus x plus 20. If it has a degree like that, don't panic, right? Plus x plus 40 plus 2x plus 10. And I'm just putting them in brackets so you understand that I'm adding all angles around the shape. Why did I put a 2 there? Turn into a quadratic. It's not a power of 0, okay? It's degrees, okay, when we're doing these types of questions. And that has to be equal to 360. You can basically get rid of all the brackets. So I'm just going to go 1, 2, 3, and another 2. That's 5x plus 20 and 40. That's 60 plus 10. That's 70. going to go 5x is equal to 360 minus 70. 5x is equal to 290. Divide both sides by 5. X is equal to 58 degrees. Calculate the vertex, the angle at each vertex. I guess we can just do that here. Right, this whole thing is equal to 58 because x is equal to 58. This angle right here would be 58 plus 20. I guess this is what I'm going to do. Sorry, angle P is equal to 58. My bad. And then here, just to get our notation right, angle Q is going to be 58 plus 20. So angle Q is 78 degrees. Angle R is going to be 58 plus 40, and that is 98 degrees. And then here, angle S is 2 times 58. Watch your bed mass here, plus 10. So this is going to be 116 plus 10, which is going to be 126 degrees. Right, so you found the angle at each of the vertices, or at each vertex. And this is the interesting one, right? Determine the exterior angle at PQR. So PQR, there is one exterior angle here. And there you have to be careful because some of you were labeling it wrong. Okay? So you either extend this side or this side, it doesn't matter. So like if you extend it this way, right, then you have this exterior angle here. This is an exterior angle. And notice that because every single interior angle is different, every single exterior angle will be different as well. So how about this? We answer C up here. C, the exterior angle there will be 180. You have to use this one. The formula 360 divided by n does not work in this case. You have to go 180 minus 78. Right, so the exterior angle at that point would be 102. Right? Because the exterior and interior, they always add up to 180 because they're along a straight line here. So you could have extended this side here this way, and then so your exterior angle would have been there. Okay. I think we're good so far here. Just wanted to review that. I'm looking at page 29, question 12. PQ and RS are parallel. We know that because they're telling us and by the markings, right? So these are our parallel lines here. Angle QTV is 38. So they already marked it in there. Angle UPV is 60. They did that. Work out the size of the angle marked with X. So they want this one here. Not too bad. I'm going to use this. I'm going to put a Y here in the meantime, right? And say that angle Y is equal to 60. Why? Because corresponding, I noticed that some of you need to brush up on your terminology, right? Corresponding angles are congruent. And then angle X is going to be 180 minus, right? It's along a straight line here. Okay. 180 minus, I'm going to start there, 38 minus Y. So angle X is going to be 180 minus 38 minus 60. And 98, so 82. And I'll just say the sum of, no, not sum of triangles, sorry. Straight angle is equal to 180. Or straight angle is supplementary, whatever you want to put. But that's my reasoning as to how this worked. Was there another way of doing it? Yes. I see at least one more way. If this is 60, then this is 120 here, right? This whole thing corresponds to this whole thing here. So technically, this whole thing should be 120. 120 minus 38 still gets you there. So that's another valid way of doing that. Whatever works for you. Determine the determine angle Q. I find this vague because Q has one, like at least two, and then never mind the straight angle, right? It has two. I think they mean this one right here. This is what they mean. So this is the one that they have a question. I'm thinking. Or anybody have the key? Did you check the key? Did I say 180? Because technically, I don't know. Q, I would say that they're asking for this or this. Well, they don't give us the three-letter notation. But if it's this that they're asking for, my game plan is this. Vertically opposite angles, right? This is 60 here. Vertically opposite angles are congruent. So that's how I got that. And then to get, what should we call that? I guess they call it Q. Angle Q is going to be 180 minus 60 minus 38. This one here. And I'll just use sum of triangles equal to 180. So angle Q is that also, am I doing this right? I'm good, right? Yeah. 82. Yeah. We could have used alternate interior, right? This here along the transversal, right? These are parallel lines, so you could have used alternate interior, so there you go. No problem. Just get used to explaining and justifying. Okay. Something like page 30, we've done a lot, like even the Page 30, question 14, you've done a lot of that kind of stuff. This is page 30, question 14. You should be comfortable with that. But explaining your reasoning is important here. I think I'm going to do this one. Okay. And order, please let me know in which order you're solving these. Okay. So I'm gonna solve for y because I see it's fairly simple to do. So angle y is equal to 80 degrees. Alternate interior angles are congruent. Right, so I just use this to get there. These are my parallel lines. I can use the transversal and jump to y. The next one I'm going to do is x. I see that they're corresponding, right? Angle x is going to be 56. Corresponding angles. And don't erase if you've done this and you have something else. Don't worry about it. It might actually vary from my answer key, most likely. I did it differently, most likely. And then to find z, I'm going to just fill in here a little bit, right? This being 80, I'm going to focus on the big triangle on the outside here. I have these two. I can find z, right? Just so you know, vertically opposite, that property will never help you. Like that doesn't justify lines being parallel ever. Like if you see like, oh, there's an 80 here and 80 there, therefore these two lines are parallel, it doesn't work that way. Okay, you can only use corresponding alternate interior, exterior, consecutive interior. Those two you can use. Okay, those four, sorry, those pairs. I did explain my reasoning. Yeah, I think that's it. And the rest, the key is out there. So let me see what else I have. Then we did the if you go to page 37, page 37, I wish I had given you a little bit more room there. This one here, for example, this one is tricky. I'm going to try my best to use the space here, but it was definitely designed to do it on loose leaf. So page 37, question 12, you have a parallelogram, okay? So you can jump this way and you can jump this way, but you have to be careful. So to find, I will use this. So I will focus on this parallel line here being parallel with this. And you see the Z, right? You should see it. Parallel, transversal, parallel. So there's the B. 30 and B are definitely alternate interiors. So I'm going to find that first here. 30 degrees. And then I will just say alternate interior angles are congruent. And I did this first, right? I'm just going to mention that. And then we can do A here. What would 65 and A be? What would we call that pair? You can hear the crickets, guys. What do we call 65 and A? They're between, right, parallel lines. Consecutive interior, right? I know you were thinking that. I know you're not, right? Like, but they're parallel lines. These are consecutive interior. So A, I'm going to do my work here, is going to be 180 minus 65, right? And that's 115. So I'm going to put down 115 here and say that consecutive interior angles are equal to 180 or are supplementary. It's up to you. Sorry, it's a bit small. So justification is important. C, I will use the straight line, straight angle property to help me out with C. Because there are three angles along this straight line here. So to find C, I'm just going to say it should be adding up to 180. I'm going to subtract A and B from it. So that is 35. No, wait a minute. Are we good? Yeah, that's good. That's good. And that is straight angle. That's all I would do there for justification, straight angle. And then D, I'm going to use, and here you have to be careful. But if you travel here and then you use this, I'm going to use the other side in green. Right, like this is a transversal connecting these two and also connecting these two. So C and D are alternate interior there. Okay. So this would be 35. And it blocks us off. Alternate interior angles are congruent. And I did that, I did this third, and this is the last thing I did. Did I post this answer key for this test? I thought I did. Okay. This chapter test is actually pretty good warm up or a very good preparation to review. The diagrams are just a little bit small, but they're really good practice. So I'm going to leave this one here. 13, I'm going to leave that up to you. There's a key out there for this. But use your alternate interior. That's always a good, and then once you have a bunch, then it's vertically opposite and sum of triangle being 180. Like those are the go-to after you've figured out a few. I'm going to go seven is a little bit I'm gonna go to page 39. 39, page 39, handwritten. Um, James, a contractor, has been hired to lay down tiles. He's considering the following shapes. All shapes have congruent sides, so they're all regular, right? Triangles and squares, is it possible? If so, what combination would work? Show all calculations and include a diagram if possible. That's just to help you understand it. Right? So I will go interior angle of a triangle we know is 60. Interior angle of a four-sided regular polygon is 90. So this is my triangle and this is my square. Okay. And so you have 360 and you got to go one at a time. Take away a triangle, take away a square. Right? And then see what are you left with. $190. No, wait, 300 minus 90, right? 210. You're left with 210. Keep going. Minus 60, minus 90. That'd be 160, right? 60 left. So you used up another triangle, another square. You want to try to use them up. Like if you have three shapes here as your options, you go through each at least once, and then you keep going. And then your goal is to get it to 0. Okay. And so all you have left is the only thing that would bring this to 0 is to use another triangle, and then you get to 0. First of all, when you get here, it works. Because of the 0, you know that it works. You will be able, you will tessellate, right? You can tessellate. And then you say a combination of, we have 3 triangles and 2 squares will work. Or using 3 tiles and 2 squares at every intersection will work, or something like that. Okay, and if you think about it, 3 times 60 is 180. 2 times 90 is 180. So 180 and 180 is 360. Just a quick check. It's fairly simple to do that. So be prepared for more than just 2 shapes, but the idea is still the same. Yeah, I think everything else is pretty straightforward, or at least maybe 41.6 is the last one. 41, page 41, question 6. Page 41. So floor designer, this is a tiling question, right? using 3 different shapes, and they all have the same length. That has to be there for it to be, it has to be regular shapes, right? Um, and one of them is a square and a hexagon. What is the third tile shape? Right? So we know that the interior angle of a square, you can just do this as well. The interior angle of a square, we know is 90. The interior angle of a hexagon, if you don't have it written down, calculate it again. Okay, is 120. So we go 360 minus 90, sorry, minus 120. So use them all once, right? Square, hex, this is 210, that's 150, right? So there's 150 remaining. What shape would work? Okay. The exterior angle of this shape would be 180 minus 150, and that's 30 degrees. We know that the exterior angle is 360 divided by n, because now we're going to find out the number of sides that we need. The shape, right, is this. It's going to give us the number of sides. So we know the exterior angle is 30, and we know that we have 360 over n. We put the 1 here, so it's multiply, divide. 360 divided by 30, n is equal to 12 sides. The third side, third shape, sorry, is a 12-sided polygon or a dodecagon. So I know that this is the interior angle I still need to cover. I'm saying, okay, I'm going to figure out how many sides that shape will have. So I'm going to figure out the exterior angle. Okay, and then figure out the number of sides to determine that. And if you wanted to check, you find the interior angle of a 12-sided. Check. Interior angle of a 12-sided is 10 times 180 divided by 12. I'm just going to double check, right? 1800 divided by 12. There you go. It's 150. And that's what you needed to close the gap. I think that's it. So, are there any questions for me in this class or at home? Bring them. Bring your questions. Let me know. And as I said, just review your notes, go through your booklets, make sure you have the 4 types, refresh a little bit on how to do regressions, because I find students forget how to press, like the buttons you press, because you can't go up anymore and find the last time you did a regression, right? So students are like, how do I do that again, right? Stat, right? Like go through the steps, just go through the motions, L1, L2, make sure you know how to zoom in. Zoom stat only works if plot 1 is turned on, right? Things like that. Oh, somebody typed something or no? Oh, okay.